Hello students, in this video we will discuss inheritance in C++. So inheritance is one of the basic functionalities which has been provided in your object-oriented programming. So the idea of inheritance is to nurture the concept of reusability and extendability. So if we go by the definition of the term inheritance, it basically means acquiring some properties from our parents by an individual. So in case of C++, inheritance is the process by which one object can acquire the properties of another object. So properties with respect to an object are basically the data members and the member function of a particular object. So inheritance is the process by which new classes called derived classes are created from existing classes called base classes. So it helps us to extend and reuse the code to form new classes which are known as my derived classes. So let us see this particular example which is representing some classes. So here we can say we have got three classes. The first class is fruit, followed by two classes which are my mango and orange. So if we see, as we all know, objects are the representation of any real life entity. So if you say that we have got a class mango and orange, so essentially both of them have to have the properties of a fruit. So we can understand or relate the concept of inheritance to this particular example, where we can say that mango and orange are some separate entities or objects which are acquiring the properties of fruit. So we can treat the fruit as base class and mango and orange as the derived class. So let's move on to the next slide. So base class. So what basically is a base class? So base class is a class which defines those qualities common to all the objects to be derived from the class. So if you relate it to the previous example, you can see that whatever properties the base class is going to have, it will be common to all the objects of the derived classes. So moving next, what is a derived class? So the classes derived from the base class are usually referred to as derived class. So again, the derived classes will contain properties which are specific to those classes only. So it includes all features of the generic base class and adds qualities specific to the derived classes. A class that does the inheriting is called the derived class. So let's move to the next slide. So there is a particular note. Derived classes can be used as a base class for another derived class. So we can have multiple inheritance where we can derive from multiple base classes. So next we'll see some basic types of inheritance that we have got in C++. So basically there are 5 types. Simple inheritance, if you see, the child class derives from only one parent. So A is the parent here and B is the child. Next we have got multiple inheritance where the child class can derive from multiple parents. Next we have multi-level inheritance where the child class is derived from another derived class. So if you see, C is the ultimate derived class which is getting derived from B. B in turn is again getting derived from A. Moving next, we have got hierarchical inheritance, where the traits of one base class are derived by several child classes. So the example we took previously, the case of fruits, so we can categorize this to hierarchical inheritance. The final one is the hybrid inheritance, which basically means combination of two or more types of inheritance. Means it can be combination of any of the previously described inheritances. So the syntax to specify inheritance is as such. So class X, this is my base class, class Y, or say we want to derive Y from X. So the basic syntax is class Y followed by a colon, then you have to give access specifier and then the base class. So base class here we are taking it as X, so Y is going to derive from X. So how it is going to derive? So this will be specified by the access specifier. So access specifier are of three types: public, protected, private. So if we specify here the access specifier as public, so what it will mean? Class Y will derive the contents of class X publicly. So we know what does public mean, we know what does private mean. So there is one more type which is protected. So we'll take up a detailed example relating to this public, protected and private in the future videos. For now, just remember that this is the basic syntax how you can specify inheritance. So next we will see a basic example for implementing single inheritance. So let's start the program. So we are trying to write down a program to implement inheritance. So let us define the classes. So let's say I am defining this particular class, which is my, or I will name the class as parent. So let's assume in public section of the class it has got a single data member, which is my, say let's name it as PID. Now according to the syntax of inheritance class, so let us say we are creating the child class which will inherit from the parent class. So class child followed by the access specifier. So this statement, what does it mean? Class child will acquire the content of the parent publicly. And so whatever contents are present in my parent, so this can be accessed publicly from the child class. So let's assume the child class is also having a single data member in the public part. So let us name the variable as CID. Now let's try to define the main function. So let us create an object child obj. So this is my object obj. So this is a object of type child. So obj dot pid equal to some value, say 56, and obj dot cid equal to say 10. So if you see, we have not explicitly defined this PID inside CID, I mean inside the child class, but this is getting inherited from this parent class. So the child class will contain both PID and CID. So we can initialize both the data members here. So if we give some cout statements to print the values, slash child id is followed by obj dot cid parent id. So obj dot pid. So if you see here, we have not although mentioned about anything about PID inside the child class, but still we can access it, is because we have derived it from the parent class. So let us run the program. Okay, before running we need to save it, so let's save it as okay. It is having an error over here. Okay, cout, sorry. So if you see the output, it is printing both the child ID and parent ID. So there is no such error in accessing the PID data member of the parent class, and we can say that child has successfully derived the content of the parent class. So that's up for now. In the next video we will discuss about the various access specifiers and what are their limitations and what are their contexts in which they are used. Thank you very much for listening. Please stay at home and stay safe.